So welcome everybody to this latest video on 160 Maths, and in this video we'll be going over the AQA GCSE Maths 2022 Higher Paper 3 number section and going through some practice exam questions relating to these topics. Now, as always, there is a copy of the questions that I go through in this video in the description below for you to download and have an attempt at before watching this video and going through the answers. So before we get started, let's just have a quick breakdown of what each of these topics all mean in terms of revision. So looking at the first one in terms of highest common factor and lowest common multiple, which again is labelled on an exam, it's HCF and LCM now. Now what you need to be able to do is make sure you know how the main differences between these two things, because a lot of students get this question wrong because they get the two things confused, but also how to correctly work this out. Now if you've got a Casio calculator, then make sure you're using your fact feature on your calculator so that you can write each of the numbers as a product of the primes. So use the fact button to write numbers as a product of their primes. And what you might find is that this is a much easier way than doing a factor tree, and it'll get you there quicker. Now in terms of error intervals, that's all talking about upper and lower bounds, so knowing how to work with those, both for finding the upper lower bounds, but also writing it as an error interval, but also answering more sort of problem solving questions, for example finding perimeters or finding maximum areas or minimum areas, etc., and also working with fractions as well. Ordering, well, that can come from several things. It can come from ordering fractions, decimals, percentages. I've seen standard form ordering come up. I've seen surds come up in ordering. So just being able to order things, and remember, ascending means smallest to largest and descending means largest to smallest. Reoccurring is converting decimals into fractions, but also showing that proving a decimal or fraction is reoccurring. So you want to be able to know how to do that. And the product rule for counting, well, that involves lists and outcomes. So finding the maximum number of possibility of events from a combination of things. And I would say that pretty much covers all of these 6 topics. So let's get straight into some example questions. So again, question 1, and again, just a reminder before we get started that a copy of these questions are in the description below for you to download, have an attempt at before continuing watching this video and going through the answers. So this question here says diaries are sold in boxes of 12, pencils are sold in boxes of 10, rulers are sold in boxes of 6. A teacher wants to buy the same number of diaries, pencils and rulers so there's no waste. Work out the smallest number of boxes for each item he could buy. So for this, what we need to do first is we need to find the lowest common multiple of 12, 10 and 6. So we're looking for the smallest number that appears in all 3 of these numbers times tables, and the answer you should have is 60. So I want 60 diaries, 60 pencils and 60 rulers. So for this, in terms of the diaries, which I'm just going to abbreviate as D, I'm going to be doing 60 divided by 12, which is 5. For the pencils, I'm going to do 60 divided by 10, and that gives me 6. And the reason why I'm choosing 12 and 10 is because that's the size of the boxes. And then for rulers, that's going to be 60 divided by 6, which is 10. So my answer then is going to be 5 boxes of diaries, 6 boxes of pencils, and 10 boxes of rulers. Then moving on to the next question, question 2, it says circle the highest common factor, the HCF, of 4x squared y and 8xy cubed. Now for this, for the highest common factor you want, now it's a different sort of rule with both numbers and letters. So for here, what we're wanting is we're wanting the highest number that divides into both the numbers, which in this case is going to be 4. And we want the lowest power of each of the letters. So here my lowest power of x is x, and the lowest power of y is y. So I'm looking for 4xy, which is my second option. For B, it says circle the lowest common multiple. So for this, I need to use the highest or the smallest number that appears in both the 4 and the 8 times table, and that's going to be 8. And then here I want the highest power of each of the letters. So here my highest power of x is x squared. My highest power of y is y cubed. So I'm looking for 8x squared y cubed, which is my third option. Then moving on to question 3, it says write 132 as a product of its primes. Now again, if you've got a calculator, you just simply press 132, press equals, and then press shift and fact, and it should give you your answer straight away, and it should give you the full marks. Where the marks, 2 marks will come from is basically using powers, so make sure you're using indices. But if I didn't have that feature on my calculator, I'll just do a factor tree. So I've got 2 times 66, then 3 times 22, and then 2 times 11, giving me a final answer of 2 squared times 3 times 11. Now I'll probably get 1 mark if I wrote this, even though it is correct, or maybe showing some evidence, but I would say if you did it straight off your calculator and wrote this down, you should get full marks for it. The next question then says work out the highest common factor of 110 and 132. So again, what we need to do here is, well, we've already done the factors of 132. So I've got 132 equals 2 times 2 times 2 times 3 times 11, and for 110 I've got 2 times 5 times 11, and so all I then need to do is circle the common factors. So I've got the HCF equals 2 times 11, and that's 22. Then moving on to question 4, it says as a product of their primes, 40 is 2 cubed times 5. Write 50 as a product of its primes. So again, I just simply either type this into my calculator or I can work it out manually. So I've got 5, 25, 2, 5, and 5. So it's 2 times 5 squared. And then for question B, it says work out the least common multiple of 40 and 50. And again, so it's looking at, again, the smallest number that appears in both the 40 and the 50 times table. I always say start with the biggest number and just write down a couple. And then from this, we've got 40, 80, 120, 160, 200, and that's where I can stop. So the answer then is 200. Now, where the 2 marks come from is just making sure that you have got the lowest common multiple. So for example, if I picked 400, that I probably should get 1 mark, but it isn't the smallest, so that's where I would lose 1 mark. Moving on to question 5, it says the height of a tree is 12 meters, correct to the nearest meter. So with the nearest meter, I'm dividing that by 2, so that gives me 0.5, so it's going to be 12 plus or minus 0.5, and the question is asking me to circle the correct error interval, and the correct one we should have is our first one, and the reason for that is because at your lower bound it can equal that number, so that should always be a less or equal to, and your upper bound should always be just a less than. And that's one way to spot. And you can see, although the numbers are the same for all 4 options, it's the inequalities that you need to pay attention to. Then moving on to question 6, it says the length of each of the regular sides of a regular pentagon is 8.4 to 1 decimal place. Complete the error interval for the length of one side. So here I've got 1 decimal place, which is this. That represents 0.1 divided by 2, so that's 0.05. So I'm doing 8.4 plus or minus 0.05, and that gives me 8.35 and 8.45. Then says complete the error interval for the perimeter. Well, the perimeter of a pentagon, well, that has 5 sides. So then the smallest is going to be 5 times 8.35. And the largest is going to be 5 times 8.45. So all I then need to do is type that into my calculator. So 5 times 8.35 gives me an answer of 41.75, and 5 times 8.45 gives me an answer of 42.25. Then moving on to question 7, which is virtually exactly the same, just with a different shape. So here it says the length of a quadrilateral is 5.2 to 1 decimal place. So here we do the same method, so it's going to be 5.15 and 5.25. And then for the perimeter, it's going to be 5.15 times 4. So 5.15 times 4 is 20.6. And 5.25 times 4 which is 21. Then moving on to question 8, it says put these probabilities in order, starting with the least likely. So again, what you want to do is with fractions and percentages, you want to convert them so that they're all the same. So I'm going to convert them so that they're all in decimals. And on a calculator paper, this should be really relatively straightforward for you. And then if you want then to have each number so it's the same number of numbers after the decimal point, that's entirely up to you. It should make it easier, but what you want to try and do is try and use the original sort of FTPs to make sure that you are substituting the correct one in. So the smallest one is going to be a quarter. The next one is 4/10. The next one is 0.0404, and then the last one is 44%. Then question 9, it says circle the smallest number from the list. And again, you could either type these into your calculator or you can just simply know. So this is going to be 0.5. This is 0.001. This is 0.004. And this is 0.1. So then which of these numbers is the smallest? Well, it's going to be this one here. Then moving on to question 10, it says prove algebraically that 2.75 recurring converts to the fraction of 124 over 45. So for this, all we then need to do is look at doing just that. So here what we've got is we've got x equals 2.75 recurring. Now what you want is you want to have the reoccurring pattern straight after the decimal point. So if I multiply that by 10, I get 27.5 recurring. Multiply that by 100 and I get 275.5 recurring. Then using these two and flipping them, I get 100x equals 275.5 recurring. 10x equals 27.5 recurring. Take the two things away and end up with 90x equals 248, and then x equals 248 divided by 90, which simplifies to give me 124 over 45, which is what they wanted me to prove. Then with question 11, it says that I then need to show that the fact that 0.9, there is a bit of an error in this particular question, so let me just correct that. So that should be 0.07 recurring. And I don't know, there must be issues with the copying of the question. So here we've got to use this to get to this. Now, 0.7 recurring divided by 10 equals 0.07 recurring. Now divided by 10 is the same as 0.7, well it's going to be 7 over 90 and then times 1 over 10, and that then becomes 7 over 90. Now again, if you're not too sure about where that's come from, well if I do 0.7 divided by 10, then that then becomes 0.7 divided by 1 over 10, well divided by 10 rather. And if I turn that into a fraction, then flip it and turns to a times, in which that's where I get that. The next question is using part A, otherwise convert 0.27 recurring into a fraction. Well, here we've got 0.27 recurring equals 0.2 plus 0.07. Now this is using part A. So this we already know is 7 over 90. And this as a fraction is 2 over 10. And so what I need to do is just write this as a single fraction. So I need a common denominator. So the common denominator is going to be 90. So if I multiply all of this by 9, I get 18 at the top plus 70 over, oh, I don't know what's gone on there, over 90. And that equals 25 over 90, which I can simplify. So 25 divided by 90 is 5 over 18. And again, if I've got this on a calculator, I can just check to make sure that 5 over 18 does give me that decimal, which it does. Then moving over to question 12, again, very, very similar. So here we've got 0.15 recurring. So I've got x equals 0.15 recurring. Times that by 10, so I get 1.5 recurring. Times that by 100, so I get 15.5 recurring. And then using these two, I get 100x equals 15.5 recurring. 10x equals 1.5 recurring. Take the two things away, and I end up with 14, and so x equals 14 over 90, which is 7 over 45. Then moving over to question 13, it says circle any fractions that are equivalent to 0.36 recurring. Well, the two answers you should have are going to be those middle two. Then with question 14, it says write 8 over 11 as a reoccurring decimal. So all you need to do here is simply perform 11 divided by 8 divided by 11 rather. So here I've got 11 outside my bus stop, and I've got 8. I'm just going to add a few zeros. And so 11 goes into 8 0 times, so I carry the 8. Then it goes in 7 times, remainder 3. Then it goes in 2 times, remainder 8, and then 7, and then 3, and then 2. And as you can see, it's going to be recurring. So then it's 0.72 recurring. Then with question 15, it says that a menu has a choice of 3 starters, 5 main and 4 desserts. How many different choices are there? Now this is where that product rule tends to come in terms of listing listing outcomes. So for this, all you need to do is basically multiply the number of options you've got for each one by itself. So in terms of the starters, I've got 3 options. So I'll just write this down. So number of options. So for the starters, I've got 3. For the mains, I've got 5. And for the desserts, I've got 4. So if I just multiply those 3 numbers together, I end up with 20 times 3, which is 60. And that there is my final answer. Then with question 16, it says that Lucy makes 5-digit numbers using these cards. How many different numbers greater than 50,000 can she make? So here I've got my first number, then I've got the second, then I've got the third, then I've got the fourth, and then I've got the fifth. So from this, in order for me to create a number that's bigger than 50,000, I need to either start with 6, 7, or 9. So there are a total of 3 options. So number of options, which is the 3, because I definitely need to start with those 3. I can't start with any of the 5. Now for the second number, well, I've got 4 cards to choose from. Then for the third one, because obviously 2 are already taken, I've got 3 left. Then for the fourth, I've only got 2 left. And then the fifth, I'm only going to have 1 card left. So then if I then multiply each of these 5 numbers together, I get the total combination, which is 72. Then moving on to our last and final example. So here it says Tom picks a 3-digit even number. The first digit is greater than 6 and the second digit is less than 7. How many different numbers could he pick? So here I've got a 3-digit number. So this is the first, this is the second, and this is the third. Now, in terms of his first digit being greater than 6, well, if it's, you can only have, well, numbers are greater than 6, either going to be 7, 8, or 9. So there are 3 options. Then for the second digit, for a number to be less than 7, well, it's either going to be 0, 1, 2, 3, 4, 5, and 6. So there are going to be 7 options. And then for the last number, it then says it's got to be an even number. So this is either going to be 0, 1, 2, 3. Oh no, it's going to be 0. Got this completely wrong. It's either going to be 0, 2, 4, 6, and 8. So there are 5 possible combinations that it could be for it to end in an even number. So the total number of possibilities is going to be 3 times 7 times 5, and that gives me an answer of 105. And there is my final answer.